All right, in this last lesson in chapter 5, we are just going to use all that we've learned with trig functions and honestly Pythagorean theorem and inverse trig functions to solve triangles. So this first question says solve the right triangle shown in the figure. This is just to give you an idea. So just notice that capital letters go with the angles, lowercase letters go on the sides. So opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. Now angle C is always our right angle, so we don't ever have to solve for C, it's just understood. So in this example, when I need to solve the triangle, I need to find the missing angle, so I need to find angle B, and I have A, so A is 7.4, little a is 20.5, and so I need to find big B, I need to find little b, and I need to find little c. Those are the things I need to find to completely solve this example. So knowing I have two angles already sure does help, right? So I know a triangle has to add up to 180. So if I subtract the 90 degree I already have, that means I have 90. And if I subtract the angle that I know, 7.4, that leaves 82.6. So angle B is 82.6 degrees. Now these are in degrees, so you don't have to worry about radian mode. We're in degree mode on these questions. Now to solve for side B or C. If I solve for side B first, okay, let's look at what is side B relative to angle A. Well, it's adjacent, and C is the hypotenuse, right? And 20.5, which was given, is my opposite side. So I'm going to use what was given, and let's look, we'll have adjacent and opposite, which would be tangent. So I'm going to use the tangent function of 7.4, and I'm going to use 20.5 divided by the unknown side of B. So when I solve for that, when I do my algebra, I'm going to end up with B equals 20.5 divided by the tangent of 7.4. And when I put that in my calculator, just to save time, I'm just going to tell you it's 157.84. Okay, now for side C, you have options. You can use Pythagorean theorem since we know two sides, or you can use another trig function. Doesn't matter, you should end up with the same thing. I'm going to go ahead and use a trig function, and finding side C would mean I need to use the opposite and hypotenuse. So that would be the sine of 7.4 is opposite over hypotenuse, right? Which is C. So when I do my math and I solve it, cross multiply and solve it, I'll end up with 20.5 divided by the sine of 7.4. And we'll put that in my calculator, it's 159.17. And I don't have any units on the side, so I'm just going to leave it. So there's my solution to this triangle. Okay, let's try the next one. Okay, this doesn't have a triangle, so I would recommend drawing a triangle. A, B, and C. Okay, let's see what's given. I'm told that little b is 1.32, little c is 18.9. Now I need to find my angles, right? And then little c. So I need big A, I need big B, and then I need little a. Okay, so how do I want to approach this? Well, to find angles, I'm going to have to use inverse functions to find angles. So let's consider what sides I have relative to angle A. I have adjacent and I have hypotenuse. So if I want the cosine of A, I have adjacent and the hypotenuse, right? Well, that just gets me the cosine of A. I don't want cosine, I want A. So I have to multiply both sides by the inverse cosine. So what's going to happen is to find angle A, I'm going to take the inverse cosine of 1.32 divided by 18.9 in my calculator. And I'm going to find out that angle A is 86 degrees. Okay. Now, I know that angle C is 90, so that's 90 left between the other two angles, right? So if this is 86, that means this one is 4 degrees. Okay, sometimes you can just do the mental math. Now to find the missing side, I can use a trig function or I can use Pythagorean theorem. So a squared plus 1.32 squared is going to be 18.9 squared. Just one way to do it. So a squared is 18.9 squared minus 1.32. When I run that in my calculator and I take the square root, I find out that a is 18.85. All right, and I've solved that triangle. Let's look at this last type of question. It says find the altitude of the isosceles triangle shown in the figure. Now, if you remember, isosceles triangle means you have two sides congruent and those two angles are congruent. All right, and to drop an altitude means it's a perpendicular bisector. So it's creating two segments that are the same length. So if I know that all of B is 3.1, I can divide it in half and find the length of this. And when I do, I get 1.55. And I'm looking for the height of the altitude. Okay, so they gave me theta, they gave me the side, and I just need the altitude. So let's think about this. The altitude relative to theta is opposite. The leg here, the 1.55, is the adjacent. So that's going to require a tangent function. So I'm going to use tangent of this angle in this format. Remember the degrees, minutes formats? Oops, 23, not 32. So tangent's going to equal, opposite is my unknown, adjacent is 1.55. And when I put that in my calculator, crank it in, and I find out that that side length is 5.93 centimeters. All right, so this lesson's a little simpler. We have a lot of tools to use to find the pieces that we're looking for in our triangles. All right, good luck. We'll see you in class.